Hi, let us solve a problem of modular multiplicative inverse that may appear in solving Chinese remainder theorem. And we insist on using Euclid's algorithm. Okay, so this is the problem that you might end up during your work in solving Chinese remainder theorem. You may get 9009 x congruent to 1, of course, because we are solving for multiplicative inverse. So the congruence should be to 1. And this is in mode 20. So we are looking for x, which is the inverse of 9009. And knowing that 9009 is much bigger than 20, you should get the remainder of 9009 divided by 20, because this will reduce the congruence to a more manageable value, because that smaller value will be smaller than the mode, which is 20 in this case. So I'm using Windows calculator, which actually allows me to immediately calculate mode, but I want to show this using a regular calculator that you are allowed to bring to exam hall, how to calculate remainder. Okay, so how to calculate remainder? Remainder is something that we get after dividing two things. What is left? That is remainder. Okay, so it is, we are calculating for 9009 divided by 20. Now this is the result of division. We don't want this. So what we want is actually what 0.45 indicates. So we don't want 450. What we do is we minus 450. We get 0.45. Multiply back with the one that we divided just now, which is 20. We get 9. So 9 is the remainder. But if you're smart, looking at the mode is 20 and the number given to you is 9009, you should get the remainder immediately as 9. So this can be reduced to 9x congruence to 1 in mode 20. Okay, now we are going to use Euclid's algorithm to solve for this. When you are using Euclid algorithm, you have to make sure that the mode is larger than the number that you are working with. Now is 9, and possibly mode is much larger than the number. Okay, because for a small number like this, it's easier for you to do it manually by inspection. As a matter of fact, when the mode is 20 or less, it's better for you to do using inspection, because some of us is better at doing it using inspection method. But if the mode is around 100, 200, or maybe 3 digits, or maybe 4-digit number, okay, so if you have that kind of large number, you have no choice but to use Euclid's algorithm. Otherwise, you may be wasting 30 minutes of your time in exam just to get the inverse. All right. So how to do this algorithm? We start with the bigger number. Why bigger number? Because we want to express it as multiplication of two things. One of it is 9 and add with a remainder. So why the mode appear here? Because in this case, we already said the mode is larger than the number that we are working with. And we want to represent 20, the mode in this case, in terms of 9, which is the number that we are looking the inverse 4, how many 9s can make up 20? So, which means 20 divided by 9 is 2, right? But 2 multiplied by 9 is 18, which means we have a remainder of 2. So, put these two number in bracket so that later when we do reverse replacement, we know which one that we are supposed to replace. We are replacing the mode. In this case, the mode is 9. Initially, mode is 20. Now the mode is 9, and the remainder is 2. Then next line, we take 9, and you should notice that this is not congruence. This is regular equation. You should take note of the operator or symbol there. 9 with relation to 2, not this 2, but this 2. 2. So 9 divided by 2 is what? Is 4, but we will have a remainder of 1. When we have remainder of 1, then that is it, okay? Because when we want to look for multiplicative inverse, the congruence should be to 1, so we should get a 1 over here as well. Next is the reverse replacement. We want to get back the equation involving 20 and 9. We put 4 and 2 to the left hand side, and then we flip everything on the left to the right and 1 to the left. So we get 1 equal to 9 minus 4 multiplied by 2. Again, this is still equation. But when we work with our inverse replacement, we are going to replace quickly with very little calculation, because what we have over here is already proof that the replacement is correct as long as our Euclid's algorithm over here is correct. But you already know that your Euclid's algorithm over here is correct by getting a 1 in the final line there. Alright, so next is we are replacing 2, because 2 is the one that in the bracket, using which one? Using the one that reflects the modular arithmetic that have 2 as the remainder. So we replace the remainder. In this case, the 2 and the 2 here. So replace with what? Replace with 20. In this case, in mode 9, 20 and 2 are identical, right? So that is why we can replace 2 with 20 over here. And we need to make the equation balance, right? We replace 20 with 2. Sorry, we replace 2 with 20. 4 remain, but we need to make up something with 9 so that the equation still balance. So over here, it is 80. So what is just 1 unit, then 80? Of course, it is 81. Divided by 9 is what? Is 9. So we get this equation that is actually the one that we are looking for to be replaced back in the reduced congruence that we get before. Some of you will follow the style of expanding this equation until you get V and W with a very detailed processes or very detailed work, but you don't have to do that because you might be making many mistakes, then you cannot get the right equation like this. So in this case, V or W is equal to 9 or 20. So if we put back everything as mode 20, what we get is 1 congruent to 9 multiplied by 9 mode 20. And comparing back to the original simplified version of the congruence that we have, x is obviously equal to 9. Oh, sorry. X in this case is congruence to 9 in mode 20, because obviously 29 is also the solution. But let us check this using our calculator. 9 multiplied by 9 is 81. sorry, 9 multiplied by 9 congruence to 81, congruence to definitely 1, congruence to 1 mod 20. We can check this using calculator. 81, I can press mod immediately, but to help you using your calculator, divide by 20 minus 4 multiply by 20. Yes, we get the remainder of 1, which means the solution is correct. So x is 9.